Okay, hi, Assalamualaikum. So here we back again. So this is our second lab video presentation for power system subject. Right. This is lab 2, 3-phase balance load in delta configuration. We are from BEI. So I am Nur Hamizah and this is my group members. Ikmal Hafiz, Idham Zali and Shahir Sahiluddin. Okay, as the equipment for lab 2 same as equipment lab 1, which is resistive load, capacitive load, inductive load, and power supply is power switch model, controllable 3-phase power supply, power quality meter with display and long-term memory for our measurement display.
Okay. Assalamualaikum and good morning everyone. Today I will explain lab 2, which is 3-phase balance load in delta configuration. So this is our group member. The equipment or component unit in for my part 1, which is balance resistive load. We use resistive load, one resistive load, one power switch module, one controllable 3-phase power supply, and one power quality meter with display long-term memory. So the procedure of our experiment of our for part 1 is set up the following circuit as in figure 1. So this is our figure 1. As you can see, this is our controllable power supply, and this is our power quality meter. This is our power quality meter with long term memory and display, and this is our resistive load. This power supply. Connect the resistor in delta configuration. Set the resistor to a level of 750 ohm. So this is our delta configuration for at our resistive load, and we again we must vary this toggle to get the value of 750 ohm of resistance value. Yes, and for power supply we must use this toggle to vary our value of voltage, which is as in lab sheet 230 volt. So we must use this toggle to get the 230 volt for voltage. So after we set all the requirement needed in the lab sheet, we must record the following result as in table list, table 1. Parameter, the parameter is given in as in lab sheet. So we must fill in the blank the value we got. So the value we got for voltage difference between live and neutral 230 volt, and between line 1 and 2 398 volt, and power. And this is our data we got. As you can see, power factor is still 1. Okay. So in this experiment we must get all this value, all this parameter. We must get all this value. That's all from me. Thank you.
Hi guys, Assalamualaikum. My name is Muhammad Syahir and I will present the part 2, which is balance inductive load. As you guys can see, there is a figure 2, which is there is the example of the connection balance inductive load. Okay, next, the procedure how to do the balance inductive load experiment, which is set the following circuit is in figure 2. Next, compute the maximum line to line current I1. The phase to phase current is I phase max equal to 0.65 and I max equal to square root 3 times I phase max. Next, switch on the variable transformer and set the line to I1 equal to 1 ampere, and reactance SL equal to QL over I square ST. And lastly, record the following results by measure the following variables and compute the reactance SL of the circuit. Then, this is the result of balanced inductive load. The value of inductor we use is 1.2 Henry. And lastly, the value of reactance, which is SL, is 352 ohm. That's all.
Okay, Assalamualaikum. My name is Muhammad Ibrahim. I will explain part 3, balanced capacitive load. Okay, this is the picture for the circuit that we must connect. Okay, I will explain to you the procedure of this part. Okay, first is you must set up the following circuit as in figure 3. Okay, you must set up the circuit like this figure. Okay, and then the second procedure is connect the capacitive load in delta configuration. Set capacitance to 2 microfarad. Okay, on this procedure, we need to connect the capacitive load in delta configuration. So the delta configuration is this one. Okay, this one. Okay, then set the capacitance to 2 microfarad. So all the capacitance is connect to value of 2 microfarad. This one. Okay, and then the third procedure is switch on the variable 3-phase power supply and set the phase voltage to 230 volt. Okay, when you're done in your connection here, so what you need to do is switch on this variable 3-phase power supply and set the phase voltage to 230 volt. This knob you must turn it to clockwise until you get the value of 230 volt. And then the fourth procedure, measure the following variable corresponding to the difference setting and compute the reactance XC of the circuit, where the formula for the reactance XC is equal to U line 1N divided with XL. And then the final procedure is to record the following result. Okay, so this is the result for this part, for part 3. This is all the parameter that we need to measure, and then the value of each of the parameter. Okay, so this parameter from U1, from U line 1N until the power factor, we can get the value from the power meter. However, the value of XL we get from this formula. Okay, from this formula. How we get SL? So this SL you bring to this, you bring to here, then XC you bring here. So it will be SL is equal to U line 1N divided with XC. Okay, that's how you get the value of XL.
Okay, so this is the comparison between star connection and delta connection. There are 6 different between them. Okay, first for star connection, P equals to IV cos theta. VP is not equal to VL. To find the VL, calculate square root 3 times VP. IP equals to IL. For power factor of star connection, power factor equals to cos theta, and the power factor must be less than delta connection. Star connection used in power transmission and it has neutral point. Okay, for delta connection, VP equals to VL. IP is not equal to IL. To make a calculation for IL is IL equal to square root 3 times IP. For PF equals to cos theta, and power factor for delta connection is always greater than star connection. And delta connection usually used in power distribution, and it has no neutral point. Okay, for the last part is conclusion. So conclusion in this lab is we can know about characteristic of resistive, capacitive and inductive of delta configuration that are different to the star configuration. Okay, second, we know value for measurement of a delta configuration always greater than value for measurement of star configuration. Loads such as resistor, capacitor and inductor influence a circuit to get the stable or good condition for this lab. Okay, so that's all. Thank you.